In this lecture, I'm going to demonstrate how do you solve an initial value problem when the differential equation is exact. Now, I'm going to assume that I don't know whether the differential equation is exact or not, but I intend to apply a method if the differential equation is exact. So the first thing is I'm going to test whether the differential equation is exact. In order to do that, first you identify what is the coefficient of dx and what is the coefficient of dy. And you're going to think that the equation is written in the form of something times dx plus something times dy equals 0. So when the equation is in this form, you assume that the solution is given by an implicit function and denote this implicit function by the Greek letter psi. You can use any other letter, doesn't matter. So assume that the Greek letter psi equal to c is the solution, implicit solution. Psi is a function of x and y. So if psi is your function that defines the implicit solution, then the partial derivative of psi with respect to x should match with the coefficient of dx, meaning that this quantity here will be d psi dx. Also, the partial derivative of psi with respect to y should match with the coefficient of dy, meaning that you have d psi dy. Okay. So now you have partial psi with respect to x, partial psi with respect to y. That tells you that you can have mixed partial derivative, and if the differential equation is exact, then the mixed partial derivative should match, and that is the way you test the differential equation is exact or not. So you calculate the mixed partial derivative, differentiate with respect to y e to the xy plus x e to the x times y, and calculate that. Remember, when you are differentiating that, you look at each individual term first to avoid mistakes. Okay, e to the x times y, differentiate it first. E to the x times y, differentiate it next. So in the first term, e to the x is a constant because you are differentiating with respect to y, and then a derivative of y is 1 plus. In the second term, x times e to the power x is constant, and you are differentiating with respect to y. Okay, so now go to the next part. Look at the coefficient of dy, which is x e to the x plus 2, and differentiate this with respect to x, because you see d psi dy, so you don't have to memorize, you want mixed partial derivative. And this time you are differentiating with respect to x. So d dx, the first term is x e to the x. First you distribute, that we avoid doing mistakes. Okay. So in the first term, x times e to the x, you are differentiating with respect to x. X times e to the x, derivative with respect to x, so is a product. So you use product rule. So take the first function, which is x, derivative of second function, which is e to the x, plus take the second function, which is e to the x, and differentiate first function x with respect to x, which is 1, plus derivative of 2 with respect to x is just 0. And you can see that left hand side equals right hand side, or this quantity here on the left and this quantity here on the right, they are equal. So the equation is exact, test, passed. It is not required to write this word, but always a good idea. You write something to indicate that the equation is exact, you have tested, test passed, so that you can avoid mistakes and it is clear. Okay. So once you know that the equation is exact, then you look at here. So you are going to consider that the coefficient of dx is d psi dx, or and coefficient of dy is d psi dy. So you can take either this part or this part, and you know is a partial derivative, and you want what? You want psi, right? Psi is your solution. So you're assuming that psi is your solution. So you want to find psi. And if you see the derivative of psi, then you can integrate that. So I'm going to start from the left side. So I'm going to write d psi dx equals e to the x y, x e to the x times y. And this is just a derivative. Well, this is also a differential equation, but you don't think too much. You consider this is a derivative, partial derivative. So you can integrate it partially. With respect to x. X e to the x times y with respect to x. So each term you integrate with respect to x. So on the left hand side you get psi, and right hand side you solve the integrals. Remember the integration now also partial. So when you are integrating with respect to x, you are going to assume that y is constant. It's because it is just reverse process of partial derivative. When you differentiate psi partially with respect to x, you assumed y is a constant. So if you integrate it again, then you assume y is a constant. So you take y out, integration of e to the x, or antiderivative of e to the x is just x, plus you take y. Now you have x e to the x, so perhaps you just write it down, x e to the x. Okay, so this is a product. So you think of how you solve it, substitution, integration by parts, whatever you can think of. So I'm thinking to use integration by part. U db equals ub minus integral of b du. Okay, so you identify which one is your db and which one is your which one is your x. So db, I'm going to take e to the x dx, which gives me v equals e to the x. Okay, so then first term I just write it down what it is. Here I have a y, I start a bracket. So integral of x e to the x dx, u dv. So u is x. Now v is e to the x minus v du. So I have an integral v, which is e to the x, du, u is x. Okay, so now you get a constant of integration. Now remember, you are assuming that y is a constant. So then the constant of integration could also be a function of y. So you write y as a function of the constant as a function of y, hy. So I'm going to denote a new function h that has to be determined. So you evaluate it, xy, you can multiply by x e to the x minus y e to the x plus h of y. So which is my psi. right? Now you see that y e to the x get cancelled, plus h of y. So at this stage, you want to find what is psi, or what is h, then what is psi. So you look at this side here. So you're going to consider this side dy is the coefficient of dy. Okay, so you differentiate. Here you can differentiate psi with respect to y, xy e to the x plus d dy, term by term. Each term you differentiate with respect to y. And from here, you assign the derivative of psi with respect to y, assign it to x e to the x plus 2. Okay, and that's it. Differentiate with respect to y, x e to the x is constant, plus y prime y equals x e to the x plus 2. And you see that x e to the x get cancelled, which is nice, and you end up with h prime y equals 2, which means h of y equals 2y. And again, we are not going to consider the constant of integration. We are ignoring that, but we are not neglecting that. It will come in the next step, you will see. So now I have everything to write down. Psi equals, so I look at here, xy e to the x plus hy, which is 2y. And now I'm going to write my solution. Psi equals c. Okay. So the constant of integration I neglected, ignored actually, did not neglect. I ignored constant of integration everywhere, but it came here. So I have the implicit solution. All I need to do is to find c, and to do that I am going to consider this initial condition. Y at x equal to 0 is -1. That means I have two values. One is for x, which is 0, and one is for y, which is -1. So I will replace x with 0, y with -1. So x with 0 means this term is multiplied by x, so this term will be 0. Y is -1 means this term is going to be -2. So I have found c equals -2 xy e to the x plus 2y -2. And from here you can see you can actually write the solution in the explicit form. So you divide everything by x e to the x plus 2. And remember, always we want to write the solution in the explicit form if it is possible. And in this case, it is possible. And hence, this is my final answer for the solution of the initial value problem. And I hope you enjoyed the lecture and you have understood and you have seen that we don't need to actually memorize any formula. All we need to do is understand the method, and we follow the steps in a natural way by looking at the situation, what needs to be done after what, or it tells you that what can be done. If you see dy dx equal to something, that tells you that all you can do is integrate. So you don't have to memorize a step that now you have to integrate. It naturally tells you. And if you have any question, let me know. Thank you.